All right, so in this section so far, we moved on from just graphing y equals ax squared to y equals ax squared plus bx plus c. And we're going to take that same idea to some word problems. We had word problems in 12.1, which were those falling object models, where we use that negative 16t squared plus c. Now we're going to move on to adding in h equals negative 16t squared plus vt plus c, where v is the upward velocity and c is still that initial height. Okay, so now we're just expanding. So we're going to use the same idea that we were doing yesterday, finding that axis of symmetry, but what that answer is going to give us is the time, and we're going to substitute that back in to find our maximum height, because remember, our vertex is always on our axis of symmetry. All right, so again, this is you guys do not have this problem in your book, so this is just paying attention up here, having your calculator out to go through the calculations. All right, so during halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. How long will it take the t-shirt to reach its maximum height? What is its maximum height? What is the range of the function that models the height of the t-shirt over time? So in here, in this problem, how long will it take the t-shirt to reach its maximum height? That's your axis of symmetry. The next part says, what is the maximum height? That's your vertex. And then the range, we'll talk about the range. How far did that t-shirt travel? Where did it start? Where did it stop? So in this case, over on this diagram, I know it might be hard to see, they're telling you right there the t-shirt is starting 5 feet above the ground. They're not launching it from 0. So the formula, remember, it was h equals negative 16t squared plus velocity times time plus that starting height. So when I take that formula and I substitute in what I know about my problem here, I have h equals negative 16t squared plus 72t, because again, my initial upward velocity was 72 feet per second. And then my starting c is that plus 5, that 5 where they're starting. So in this case, to find how long it'll take to reach my maximum height, t is going to equal negative velocity divided by 2 times. In this case, it's going to be negative 16. That's not going to change because a is going to be negative 16. So my initial velocity, so I have t equals negative 72 divided by negative 32. And what is negative 72 divided by negative 32? 2.25. So the time is 2.25. So this t-shirt is going to reach its maximum height in 2.25 seconds. So maximum height time is 2.25 seconds. That's one part of what they're asking me for. To find out what that height is, now I have to take that time and substitute it back in. So my height is negative 16 times 2.25 squared plus 72 times 2.25 plus 5. So again, we worked on this, put this in our calculator. What is negative 16 times 2.25 squared plus 72 times 2.25 plus 5. 86. So if h equals 86, that means my maximum height is 86 feet. So really the coordinates of my vertex are 2.25, 86. That's what those two values are. Now the last part says, well, what is the range of the function that models the height of the t-shirt over time? The question you have to ask yourself, did the t-shirt ever hit the ground? Why not? It got caught at 35 feet. So the t-shirt, what was the lowest that t-shirt was ever at in this problem? 5. It started, we started at 5 feet. So the lowest that t-shirt ever was 5 feet. So my range would be 5 is less than or equal to h, which is my height, is less than or equal. And what was my maximum height? 86. So my range for my height is between 5 and 86. Yes, it was caught at 35 on the way down, but at one point it was as low as 5 feet. But you have to be cautious. Some problems, the object will hit the ground. And if it does hit the ground, then your height would have a low end of 0. Because if it hits the ground, we're at 0. So make sure you pay attention on a problem. Did it ever hit the ground? All right, now let's go ahead and take a look at your problem in the book, which is taking my problem, but changing that initial upward velocity to 64 feet per second. So again, if we start with the equation, h equals negative 16t squared plus vt plus c. And again, it's using the problem I just showed you, which means my starting height is still going to be 5 feet. The only difference here is my initial velocity is changing. So h equals negative 16 t squared plus 64 t plus 5, because 5 was my starting height. So the first part, how long will it take the t-shirt to reach its maximum height? So time is going to equal negative v over 2a. Basically, that negative 16 is going to be a. So my time is going to be negative 64 over 2 times negative 16. So my time is negative 64 divided by negative 32. So what is my time? 2. So my maximum height time is 2 seconds, which we expected should be less. The initial velocity wasn't as great, which means that we also know it's not going to go as high if it's not starting with the same initial velocity. Now we have to take the 2 and substitute it in for t. So h equals negative 16 times 2 squared plus 64 times 2 plus 5. And if we calculate that out, what do we get? What is my maximum height on this problem? Should be getting 69 feet. So my max height is 69 feet. which again means my vertex has the ordered pair 2, 69. And the last part, what is the range of the function that models the height of the t-shirt over time? Did the t-shirt ever hit the ground? No, they're still saying it got caught at 35 feet above the court. So the lowest that t-shirt was that initial starting height of 5 feet. And how high did it get? Got up to 69 feet. So there's the 3 parts. Had a maximum height time of 2 seconds. That maximum height was 69 feet. So the height has a range of between 5 and 69 feet. You guys have problems 3 and 4 in your book right there. I'm going to pause and give you a little bit of time. Number 4 is a little bit different. So make sure and talk it over in your groups. All right, so let's go ahead and look at the answers to 3 and 4. Number 3, we had an initial velocity of 30 feet, so negative 30 over 2 times negative 16, or 30 over 32. I left it in fraction form. I know a lot of you put it in decimal, which is approximately 0.94, and that's fine. So that was how long it would take to reach its maximum height. So here is my max height, or my max time. Then I substituted that back in. So I got like 20 and 1/16. So I know a lot of you got it as a decimal, just over 20 feet. So this is our max height. And the range here, this is important. Did anyone ever catch this baseball? No. So what had to have happened to it? It had to hit the ground. So your range had to be from 0 up to that 20, just over 20 feet. Because this time, no one caught it. So the ball had to come back down. Again, that's something we have to pay attention to. Did the object get caught or not? The second one, a lot of you got stuck with the 100 feet of string. But you have to come, they gave you this equation here. A equals negative x squared plus 50x. That's where we have to keep our focus and use that 50 because that's what's in front of the x. So negative 50 over 2 times negative 1 is 50 divided by 2, or 25 feet. That 25 feet, that is my width. The width is 25 feet. Then I substitute that back into the equation to get 625 feet. That's my max area. And again, here my range is 0. Now there's a difference. Up here the range, I said 0 is less than or equal. I can't have an area of 0. That means it doesn't exist. So 0 is less than the area is less than or equal to 625. So that's the difference. I can have the ball hit the ground up here, but down here I can't have an area of 0. That means I don't have a 4-sided figure anymore. So 0 is less than. That's the difference in the range, why we use less than or equal up here and why we just use less than here. You have 4 graphing problems. I'm going to pause a little bit longer to give you time to get those done before we go over them. Okay, let's take a look at the first 2 graphs to make sure we're on the right track. So here's 5 and 6. So 5 was y equals x squared minus 4x plus 1. So my axis of symmetry, since the b term there is already negative, I have a negative 4. That means when I substitute it in for my axis of symmetry, it's a negative 4 divided by 2 times 1. So 4 over 2, or 2. And then I didn't show the whole t-chart here, but if we do a t-chart, do your x and y values. I know that 2 is going to be in the middle here, so I'm going to do 1 and 0, 3 and 4. I already know that 2 gives me -3 because I already worked that out. It looks like 0 gives me 1, 1 gives me -2, 3 gives me -2, 4 gives me 1. So there would be my t-chart to go with that. Number 6, -2x squared minus 8x minus 3. Again, the b value is already negative, so when you substitute it in for your axis of symmetry, make sure it's a -8 divided by 2 times -2. So 8 divided by -4, so my axis of symmetry is -2. So my t-chart, if I'm doing -2 is my vertex, so on to the left of that would be -3 and -4, -1 and 0. So at -2, my y value was 5. At -3, it was 3. At -4, was -3. And that would be my t-chart to help me graph. I'm going to pause for just another moment for you to finish 7 and 8. All right, so 7 and 8. 7, we had a b value of +6. So -6 divided by 2 times 3, -6 divided by 6 gave me an axis of symmetry of -1. Do my t-chart. So I know -1 is where my vertex is, so 2 to the left would be -2, -3. 2 to the right would be 0 and 1. So at -1, I'm at -1, so my vertex is -1, -1. At -2 and 0, I'm at 2. And I'm going to say my 3 and my 1 must go off the chart. 11. For number 8, b value is positive, but my a value is negative, so make sure you get that. So -2 over 2 times -1. -2 divided by -2 is +1. So my t-chart, 2 to the left of 1 is 0 and -1. 2 to the right is 2 and 3. So at my vertex was at 1, -4. At 0, I was at -5, which means at 2, I was at -5. And what am I at -1 and 3? Thank you. So we're at the point we are going to have a quiz on the first 2 lessons of this chapter next week. We should be able to do this graphing whether it's an ax squared plus c or an ax squared plus bx plus c.